Good evening, everybody. Tonight is lesson 7 of Lambda School's Mini Bootcamp. My name is Deandra Ryan Moss, and I am an instructor here at Lambda School. And hold on a moment. It looks like we might have an issue with the link, so let me make sure that is resolved before I start teaching you guys for tonight. One moment. Okay, it looks like Mitchell has sent out the correct link in Slack. So hopefully you guys are all with me. Before we jump into the lesson, I'm going to tell you a little bit about Lambda School in case you are new to this series. So Lambda School is an online school for computer science and web development. It is a 6-month course in which we get you ready for a job in the field. So at the start, you're at the point coming out of this boot camp. You know a little bit about programming. By the end, you are ready to work in the field. So we're going to teach you a variety of topics: front-end development, back-end development, as well as computer science fundamentals. So a little bit about our model, which is that we want to make sure that this education is available to anyone who is willing and capable of learning it. So one of the things we do that I've mentioned is that we have a de-risked model. That means that if you don't want to pay up front, you don't have to. You can defer payment until after you get your full-time job, making over 50K. So we do not make any money unless you get us a job. And so one thing that puts upon us is that we are extremely invested in making sure that you get a job, because we don't get paid unless you get that job. So you might be wondering what we do to ensure that. Well, the first and most fundamental thing we do is make sure that our curriculum is really solid, that we're actually teaching you the things that you need to know to get hired and work out in the world. The next thing we do is make sure that we're only bringing really awesome people into Lambda School. But beyond that, we're very serious about the actual job search process. So we have an entire hiring team. We are going to help you build a resume. We are going to help you with your online presence, your GitHub, your LinkedIn. And we also have hiring partners. So there are some companies that we work with directly, so that when they're looking for someone who maps your skill set coming out of Lambda School, we can connect you directly. So we have a lot of cool systems in place to make sure that you get that job, because that's what you're here for, and that's what we're here to bring to you. So that's Lambda School for you. If you're interested in our 6-month full-time program or our year-long part-time program, please reach out to the admissions team and we can get you started on that application process. So that brings me to this, which is the Mini Bootcamp. It is a 3-week series in which I teach you some web development fundamentals. So if you are jumping in for the first time, this might not be the best place to start, because we are now on lesson 4 of JavaScript and everything is starting to build upon itself. So I would definitely recommend you go back and check out old videos, or maybe wait until May's session. But if you're joining us again, let's go ahead and jump on into some more JavaScript topics. So last night we learned all about arrays, which were data structures. This was the first time that we were introduced to this idea of multiple data points being stored in one variable. And we're going to be doing more of that today. So we are going to take a look at objects today, which are another data structure. They're really useful and they're really fundamental to how JavaScript even works at the core. So we've got a lot of cool stuff to cover tonight. Let me go ahead and share my screen so that we can start programming. All right. Well, let me do a quick review of what we saw last night with arrays, and then I will jump into objects. So at the very core, we saw that the way to instantiate an array looks like this. So let me go ahead and populate this. All right, so I have just declared an array. As with any other variable, we use our variable keyword, we name it whatever we want, use the single equal sign for assignment, and then the specific syntax for an array is that we will use these hard brackets to indicate that we are declaring an array. And everything inside will be separated by commas. So we are welcome to start with an empty array if we'd like. This is perfectly valid syntax for creating an array. But if we want to go ahead and populate it from the get-go, we can actually put items into the array directly. Once we've created our array, then a variety of different properties and methods are available to us. So we could easily check the length. We could also do things like popping to remove an item from the end, which would, let me go ahead and get the array up on there. So after we've popped, the final thing is missing. Or we could use a method like push, which adds another item onto the end of the array. So arrays are really useful for storing multiple pieces of like data in one useful place. And at the core, arrays really are just ordered lists. And as we saw, they don't necessarily need to have an order, but they work really well for putting different items that are related in organizing them together in an orderly manner. So now let's look at objects. So objects, as I mentioned, are a different type of data structure. So whereas arrays are great for ordered items, objects are not ordered. So this is an idea I'm going to keep coming back to. They're not ordered, but they are labeled. So let me show you another example of an array. And I briefly mentioned something like this last night. So if I created an array called myInfo, and let's say that I stored some information about myself in here. So I might put in my first name, Deandra. Maybe I put in my social security number. This is totally my social, so no one steal my identity. Definitely not my social. And then let's say that I also put in my hometown. And finally, I put in the current town that I live in. So this is kind of an interesting array because in one sense, I mean, certainly the data is not ordered in any way. But as I mentioned, that not every single array will be ordered in a meaningful way. We see that the items in here are they're common in that they have to do with me, but they're all kind of different types of things. So this is a name, this is a social, these are both towns or cities, but there's also a lot of ambiguity here. So it's pretty clear to hear what's going on when I'm explaining it to you because I told you, all right, this is my name, this is this thing, hometown, current location. But if you were to just see this array floating out in the world of programming, it would be very unclear what was going on, especially these last two items because they're both towns, but it's not clear which one is which, what they refer to. So this is actually a bad array example. So this is a scenario where you wouldn't really want to use an array because putting these items in an array leaves a lot of information unsaid. So in this case, an object is going to be perfect because the data is not ordered and some labeling would really help us out. So let me go ahead and I'll comment out this what not to do example and create instead a myInfo object. So I'm going to create this thing and then I will break down for you all of the syntax. So now I'm putting all these items in, but I get to add labeling. And then we can do hometown. Finally. Okay, so this is an object. As you can see, even just based on the syntax, there are some similarities to what we saw with the array, but definitely some differences as well. For starters, we use these curly brackets instead of the hard brackets. And this is a really simple way to let, when the computer is reading our code, it now knows, okay, we have an object coming. So, if I tried to use these array brackets instead of the curly brackets, and we ran this, we would get this syntax error because it's not, the information in here is not of the expected format for an array. But if we use curly brackets, we're good to go. So we use curly brackets. As with an array, the different pieces of information here are separated by commas. But instead of just putting one value in each slot, we put a pair. We put a key value pair. So we have the key, which is the label, so name in this case, and then we have the actual value, which is what my name is, and so forth. So we have 4 keys. You'll also hear me call these properties. So 4 keys, 4 properties, and then the actual values associated with them. And the key value pairs will always be separated by a semicolon. And then one final note on syntax is that whereas this array up here, I put on one line, that's just for readability's sake. So as I mentioned before, white space is, the computer doesn't care about white space. White space just makes it more, or new lines just make the code more readable for a human. So I could totally declare an array like this, and that would be no problem. There's just no need to if everything fits on one line. Whereas with objects, they tend to get cluttered and hard to read when you put them on one line. So usually you'll separate them out like this, but if you did put them on one line, that would be fine as well. So, all right, so here is our MyInfo object. So let's go ahead and take a look at how to use this thing. So there's a lot of similarities between arrays. So let me actually declare a different array up here. Okay, so when we're looking up individual items in arrays, we want to use bracket notation. So if I went down here and said array at index 0, this would give me the first item on the array. And if I did index 2, this would give me that third item. As another reminder, we use 0 indexing for arrays. So this is item 0, item 1, item 2, etc. So similarly, we can also use bracket notation with objects. But instead of putting in an index, we put in a key. So I could do MyInfo name. Let me change that too. So using bracket notation in a very similar way to how we've seen with arrays, I could look up name, or I could look up hometown if I wanted. So now, once again, there's no sense of order in terms of this, even though I've, of course, literally declared these things in order. When we're looking up, we don't care about the order. We only care about what the name of the keys are. That is how we access items from inside of an object. So that is bracket notation, pretty similar to what you've seen with arrays. And of course, we can use this for lookups. We can also use this for reassigning. So if I wanted to change my hometown and do the full name of the city, I could do that. And then when I do MyInfo, you see that it's been updated. So this is just that very similar syntax to variable assigning, which is that we actually look up the value using that notation. We have a single equal sign for assignment, and then we put the new value over here on the other side of the equal sign. So in this way, we've updated our object. So as well as updating, we can also delete items. So I could go ahead and use the keyword delete, followed by the name of the object and the name of the key. And now when I go ahead and put my info in, it pops up and we can see that the hometown has been removed. Another option is that I could just reassign this thing to undefined. Notice that over here, this key is totally missing when we log the object, whereas now it's on there, but it's set to undefined. So I personally prefer the first method because you're actually clearing out the info, but there might be scenarios in which you still want this key to exist on here, but you don't want there to be any defined value on here. So that is one way of manipulating objects. We can use this bracket notation to go through and reassign values, grab values, assign new values, delete them. Oh yes, that gives me another opportunity to show you if I wanted to add a key on here, such as maybe a Boolean, like we could do is female, and that would of course be true. Same thing. We can just use this assignment in that same way. And now it will add that extra key onto our object. So bracket notation is going to be the most familiar to you guys at this moment because it's similar to what we've seen on an array. But what I've shown you is actually not the preferred way of manipulating objects. So I did want to introduce it to you, but now I'm going to show you everything we just saw, but using dot notation. And dot notation is actually the best way to deal with objects in almost every case. So myInfo.name. Instead of doing myInfo bracket name, we can just do dot name. And notice that we don't make name a string in this case. This will throw an error. We just want dot name. So we can, when we explicitly know what the name of our keys are, we always want to use dot notation. And in this way, we can pull my name off. And the same goes for reassigning. So if I wanted to put in my full name instead, I could use dot notation. And then if I go ahead and look at the entire object, now my name has been updated. Same thing if I wanted to delete or add a new key, I could just use dot notation. And as I mentioned, dot notation is the preferred way to go when you explicitly know, okay, I want to grab the social security number key, I want to grab the hometown, etc. So bracket notation will work, but in these examples, you would always want to use dot notation. So this will bring me to the third way to access items in an object. And this is the scenario when you actually would want to use brackets. So let's say that I had this variable called key name. And in this case, we'll set it equal to hometown. Let's do current town. I don't think we've used that one yet. So we have this variable called key name. Right now, I've declared it so that it's set equal to current town. But maybe this is something that's changing, or maybe this is a variable that's coming to us from some user input or some third-party function or some other piece of code that we're not messing with right now. So we could have this kind of mystery variable called key name. And we don't know what key it refers to. We just know it's one of the keys on our object. So in this case, we would want to use bracket notation. So if we did myInfo.keyname, this isn't going to work. It's going to look for something explicitly called keyname. And as we can see, there's no property called keyname on here. But using bracket notation, we can actually pass in a variable. And it will actually check what is the string that this keyname is equal to, and it will look for that. So it goes ahead and pulls up Bisbee successfully. This can't be a string, or once again, it'll explicitly look for a key called keyname. So we want to pass in the variable itself, not so we want to pass in the variable itself, not the string version of the variable name. And in that way, we can look it up. So as a little summary of the difference between dot and bracket notation, they're both ways of doing the same thing. They're both ways of getting info from an object. They're ways of reassigning properties on an object. You can use them to delete properties on an object. The big difference is that bracket notation you want to use when you have a variable. So if you have some sort of variable that's set to a key name, you would use bracket notation like I have here. If you literally know what the name of the property is, then you would use dot notation. So, like so. So that is the ins and outs of how to access information on an object. So that is like the most fundamental Object 101, knowing both bracket and dot notation and understanding the difference of when you would use either. Now let's talk a little bit about properties and methods. So I'm going to once again bring us back to this array example. So in arrays, we saw that we have this nice little built-in property called length. We've seen some other properties on some other items, like we saw that strings have length as well. And this, of course, gives us the value of how many items are in the array. We also saw that arrays have methods, as I went over at the beginning. So we could do something like pop, which is a function that's built onto all arrays that pops out the very last item in the array, leaving us with only the first two items left. So we've gone over this a lot as I've introduced different data types in JavaScript. This idea that different types of data have different properties, different methods built into them that allow this use. So you're probably thinking, okay, now we're going to learn about methods on objects or properties on objects. And it's a little weird when it comes to objects because it's not quite accurate to say that there are no methods on objects, but there aren't any object-specific methods. So for example, one method on an object is something called toString, and it just creates a string version. So it's a little unsatisfying actually with objects because it just stringifies this object thing instead of telling us what's actually inside of it. But toString isn't something that's specific to objects. It's something that's on everything. So I could also do array.toString, or I could do, if I had a number, I could do number.toString, and it creates a string version of my number. I could do it with Booleans. So there are these built-in methods that every single thing has, like toString, and objects have those too, but there aren't any methods that are exactly object-specific. Instead, when you're dealing with objects, you actually write the methods yourself. So now, instead of using built-in methods that already exist for us, we get to create our own. So let's say that we want a method on MyInfo called sayHi. SayHi is going to be a function, of course, because methods are functions. And all sayHi does is it console.logs the word hi. So now if I do myinfo.sayHi, we can see that in white over here on the console, the word hi has appeared. So the syntax looks exactly the same as we're used to seeing with methods. We have a dot followed by the name of the function, followed by the parentheses for the function call. But in this case, instead of using a built-in method that already exists, we're actually explicitly writing it. So the syntax for this is the same as creating a new property. We just use the dot notation to specify what it's going to be called, and then we follow it by this anonymous function with the functionality built in. So there as well, if we wanted to, we could write this method directly into our initial declaration of the object. So I could do sayHi over here, follow it by a semicolon, and let me just do a little copy and paste. I'll bring this over. So this is just another way of accomplishing exactly the same thing. So whereas up here we have everything in here is a key value pair. So up here we have this key name followed by the value of a string. Down here it's the same thing with the method. We have sayHi, which is just our key name, the name of our method. And then following it, we have an anonymous function, which is the value that goes in. The only difference is that while we would refer to these as properties, we'd refer to this one as a method because it is a function. So beyond that, the syntax is just the same. So in that way, we have created this method on MyInfo called sayHi, and it still runs as expected. Let me show you a slightly more complicated method that we could create. Instead of sayHi, let's call this sayName. So now I'm going to say, hello, I am, and then I will want to follow this by my name. So I could just hard code in my name, right? And now we have, so we've hard coded in, hello, I am Deandra. So when I call myinfo.sayname, I introduce myself, but this isn't very dynamic. So for example, if I change my name, myinfo.name to Jose, oops, the string Jose. Now, when I call sayname, it still introduces myself as Deandra because it's hard-coded in. So we don't want to do that. Instead, we want to do myinfo.name. So we actually pass in myinfo.name into this console log, and now it's dynamic. If I redefine my name, this method updates. And if I just keep it as is, it introduces using Deandra. So that's exactly how we want to use methods. Whenever methods are using properties from inside the object, which they often are, we want to make sure that we're actually referencing the property instead of hard coding in the value, because the value could change. Now, I want to show you one more way of accomplishing this, which is with a keyword called this. So this is a keyword that refers to the object that a method is being called on. So essentially, in this case, this refers to my info. So to say this dot name is exactly the same as saying my info dot name. And you might be wondering, well, why would we use this when that's a little more confusing and they accomplish the same thing? In this example, I probably would not use the keyword this. I probably would directly say my info dot name because there's no ambiguity. But as we will see tomorrow, there are cases when you have to use the keyword this. It becomes really critical to use it. So I wanted to just introduce it to you guys, get it floating around in your heads, and we'll see a lot more of this keyword tomorrow. The most important takeaway is it just refers to whichever object the method is living inside of. So that is a little introduction to writing methods onto objects and the keyword this and how that can play in. Once again, in summary, we've seen a lot of methods so far, but we've seen things that are built in by JavaScript already. So things like array.pop or math.random or even console.log. All of these are methods that are built in. They're available to us to use automatically. But now we're looking at methods in a slightly different way, which is that we are writing them ourselves. So that is how methods work on objects. Now let me talk to you a little bit about looping. So as a reminder from last night, if we want to loop through an array, we would want to use a for loop. So if I want to log all the items in this array, I can do set up my loop as long as I is less than array.length and then increment I. And then within my for loop, I could console log array at index I. So in this case, this line of code, line 5, will run 3 different times with the value of I changing each time, so that when we run it, we see that all 3 items from our array are logged out to the console. So if you're looking closely, you might have noticed that this for loop is really not going to work for our object. First and foremost, because we don't look things up based on numbers, right? So the for loop will provide us with these indices, which are great for looking up things on arrays, but that doesn't really work if we're trying to look something up on an object. So let me comment out that loop, and then I want to do something similar down here with our object. So now, instead of using a for loop, we're going to use something called a for in loop. The syntax is pretty similar, but actually a little simpler. So we'll do let key, for let key in my info. There we go. So this is actually, as I said, a little simpler than a for loop in that we actually just have to write 4 words inside of the parentheses in order to get off the ground. So we start by declaring a variable. In this case, I've called it key. This could be called anything. It could be called blah, blah, but we wouldn't want to call it that because that wouldn't be very clear. So just as in a for loop, we almost always use I as our standard indices, we want to do the same in a for in loop. Our kind of default variable name we use is key because it's just super descriptive and versatile. So we say let key, and then we use in, which is another keyword, my info. So that will be the object we loop through. So we're going to loop through every single key within this object of my info. So for starters, I will go ahead and just console log key. Run this. So we can see that this line of code, line 20, has run 5 different times for the 5 different keys that are in my info. So over here, we see that the 5 different keys have been logged to the console. And that is nice if we want to know what the keys are inside of our object. Let me add a little label there. So here are our keys, but we also want to know what the properties are. And in fact, more often, we're more interested in the actual values over here than what the names of the keys are. So in this case, we would use bracket notation to get the values. So we have this variable key, but it's not the explicit name of any property. So that's how we know that we use bracket notation. As a reminder, bracket notation is always used when we're looking up using a variable instead of the literal name of the key. So now, if we go ahead and run this loop, we can see both lines 20 and 21 have been executed 5 different times. So we have up here 5 different key value pairs for each of these items in here. So that is a for in loop. Very similar to a for loop, just different syntax and different use cases. For loops, you're going to want to use with arrays. For in loops, you're going to want to use with objects. So that is the gist. Now, let me talk a little bit about why you want to use each with each other. So as I mentioned, it wouldn't really make sense to use a for loop for an object because we're just giving these indices, right? So there's no way to look up. There actually is kind of a convoluted way to look up items inside of an object using an index, but it's really not good practice at all. But for the basic use case, yeah, this doesn't set us up very well to loop through an object. But what about the other way? Could we use a for in loop to look through an array? Let's go ahead and try and find out. So if instead of doing for all the keys in my info, let's try for all the keys in array. We want to see what the key is and what the value is. So let's see if this works. Well, on the surface, it looks like it does work, right? We have our keys set to our indices, and then we got under values each item in the array. So this is one of those places where you have to tread lightly because, yes, in this case, it seems that the for in loop worked about as expected, but that's not always what's going to happen. So you really do want to stick with for loops for arrays, and let me show you why. So I'm going to go ahead and assign a new item onto this array at index 5. So at index 5, I'm going to put in actually the final thing. So if we go down here and see what our array looks like, we have an item, we have this other thing, these 3 things we declared from the get-go, and then it lets us know that we have 2 empty items in here, and then at the end, we have this final item that I've put on index 5. So there's actually 6 items in this array. It's just that 2 of them are empty. So now let's try using our for loop, or our for in loop. Notice that it skipped the 2 empty items. So it appears that there are 4 items in here when there are actually 6. So that is a little bit confusing. If instead we used our for loop, which is designed for arrays, then it acknowledges that there are 2 items in here. There are these 2 undefined items in here. And that is, conceptually, that's how we want to think about an array. Even if items are missing in the middle, we still would say that this thing has 6 items, and array.length would be equal to 6. So that's just one example of why you wouldn't want to use a for in loop for an array. There are other reasons for it, but that's starting to get advanced. The biggest takeaway here is that for loops are great for arrays, for in loops are great for objects. But we're kind of breaking the rules here. So let me go ahead and play around and do something a little crazier. So we saw that when we put an array into the for loop, it maybe sometimes didn't work exactly as planned, but it still worked out all right. Let's do something even crazier and put a string in. So if I created this string that says learning about objects, and I'm going to go ahead and plug it into the loop, what do you think, guys? Is this going to totally crash, or is it going to work? Well, actually, it worked surprisingly well. So it went through and actually looped through all the characters in here. So we see that we have an L, then an E, then an A, then an R, etc. So surprisingly, this actually kind of worked pretty well on a string. Let's try something even crazier. Let's try a Boolean. So in this case, it seems like these lines of code never ran. So nothing really interesting happened, but notice that the code never crashed. So you might be wondering where I'm going with all of this. And the big thing that I want to bring to your attention is that, doesn't it seem kind of strange that the for in loop let us loop through the array and let us loop through the string and even let us loop through the Boolean, even though it didn't really do anything, when these loops are designed for objects? So you would kind of think, hey, if these loops aren't designed for strings, or if they aren't designed for arrays, why don't they throw us an error when we try to do that? And that is a really good question. So that is kind of the first weird thing I want to point your attention to, which is that for some reason, no matter what we throw in a for in loop, it doesn't crash the code. It might not be useful, but it doesn't crash the code. The next thing I want to bring up that I touched on earlier, that's a little bit strange about what we've learned tonight, is this idea of properties and methods, right? So we've heard these two terms, property and method, thrown around since last Thursday, since we learned our very intro to JavaScript lesson. So we've always seen them referred to in this one specific way, which is that a property is something that's built in on some different data type in JavaScript. So for example, an array has the property of length. It's something that already exists that we as a user can look up. It's documented online. But now down here, all of a sudden, property refers to something that we're building. Property is something that we make up ourselves. Same thing with methods. We've seen methods so far as something that are built in by JavaScript, like array.pop. This is something that pre-exists so that we can use it. But as I mentioned before, now we're using the word method in a different way. We're using it to refer to something that we create, we name, we define. And all this stuff seems really confusing, right? Like, why did we decide to use these two terms in these two different ways? And it actually gets at something really fundamental that's going on here. So I hope you guys are ready for this, because we are about to have a pretty crazy twist ending to this lesson, which is that it turns out that every single thing in JavaScript is an object. So of course my info is an object. That's what we learned today. But this array is also an object. And if I create a string, the string is also an object. Boolean, object. So from the get-go, this probably sounds like utter nonsense. This sounds like some sort of crazy new agey conclusion about how secretly all types in JavaScript are one and there's the eternal oneness of objects or something crazy like that. But there's something really deep and subtle going on here. And this is, I think, conceptually probably the most difficult topic that I will have introduced to you guys. So I do not expect you to understand this in detail or understand this deeply by the end of this lesson, but I want to introduce this idea to you because it's really cool and it really starts to give you insight into what is actually going on here. So with arrays, yes, this is an array, but it's also an object. Yes, this is a string, but it's also an object. This is a Boolean, but it's also an object. This thing is just an object. So when in day-to-day speaking, when we refer to an object, we're usually referring to something like this, something with little curly brackets on it that has these key value pairs. But behind the scenes, these things are objects too. So think about it this way. An array is deep down at the core an object, but it's wearing an array costume, which means that we use this certain syntax to declare it. We use these brackets. We can use these built-in methods like array.pop. And any old object doesn't have a pop on it. Strings don't have pop. Booleans don't have pops. These kind of vanilla objects don't have pop. So pop is specific to the array costume. And the property length. We know that strings also have length, but not everything has a length. Whereas something like toString, which I showed you earlier, every single thing has toString because that is an object method. That's something that's going to be common to every single thing inside of JavaScript. So if we're thinking about all of these different types that I've introduced you to, like arrays, strings, Booleans, as being objects wearing different costumes. So an array is an object wearing an array costume. A string is a string wearing, or an object wearing a string costume, etc. We could think of this thing as being like the narrator. It's just an object. It's not trying to be anything else. It doesn't have any built-in frills. It's just an object. And so when we're creating objects, it's our responsibility to actually define what the properties and methods are. Whereas when we're creating these dressed up objects, they already have those properties and methods built in on them. So once again, this is a really subtle point, and it really gets at this idea of what is fundamentally going on behind the scenes. But in day-to-day speaking, you wouldn't normally call an array an object. You'd normally just call it an array. But it's important to remember that behind the scenes, it is secretly still an object. Okay, well, I hope that I haven't melted your mind too much on this. Luckily, that is all the topics that we need to cover tonight, so we have plenty of times for questions. And I see that there's already a question waiting for me in the question channel, which is, should we use for in loops for arrays or not? And I think that's a great question because I know that maybe I didn't make that super clear. So for arrays, you want to always use a for loop. So you want to use that for loop that we're used to, where you actually loop through the index and then access items in the array based on the indices. If you use a for in loop, it won't throw an error, and it might work the way you expect, but it might not. So that's why you don't want to use a for in loop for an array, because it's kind of a wild card. It usually will work as expected, but in some special cases, it's going to break down, and you don't want to take that risk. So that's why you use a for loop for an array. All right, I see a couple other people typing. Okay, so Erin has asked a couple of syntax questions about objects, which I think are both really good. So first he asked about the semicolon at the end. And yes, the semicolon belongs here. As a little reminder, if we leave off the semicolon, we're usually going to be fine, but that's another one of those cases where there are situations where leaving off the semicolon will create problems. So it's better to put a semicolon on the end whenever we declare an object. The next question, the kind of part 2 of Erin's question, was about this trailing comma. So that's actually a really good point. This is something that's new to JavaScript. So it used to be that when I created an object, I would put in, key 1, key 2, and then there would be no comma here. The problem with that is that, let's say I want to add 3, it's really easy to forget this comma. And so I can tell you that just in my professional life, I've had this happen a million times where I'm like, why is the code broken? And it turns out that I forgot that comma. So as a remedy for this really common problem, they updated the syntax so that you can put a comma after every single line in an object, even the last one. And that way you just always put a comma on the end. And then when you add a new key, you put the comma on and you don't have to worry about going back and adding an extra comma before. Okay, we have another question, which would be a guide for using, Ryan asked about the for each loop. So yes, we have not seen every single loop there is. There's also something called a while loop, which in my experience, you almost never use, admittedly. And there's something called a for each loop. So a for each loop is a little more advanced, and we will actually be covering that next week. So I don't want to answer your question yet, Ryan, because it deserves a lot of time and attention, and we will be able to get to that in one of our lessons next week. Does anyone else have any questions about all of this? Okay, it looks like we are good to go for tonight then. I'll let you guys go just a little bit early. As a reminder, we have some homework on this stuff. I hope you guys are getting used to using the command line to running your tests. If you need a refresher on that, feel free to ask in Slack or to go and check out our lesson from a couple nights ago. As always, if you get stuck on these homework assignments, I would say first line of defense is try and Google it. Googling is such a great, important skill, so make sure you're using that. The next line of defense would be to ask questions. You can ask questions in either the questions channel or you can ask in the channel for tonight's lesson specifically, for lesson 7. And then, as always, feel free to reach out to me directly if you need anything, but I might not be able to answer your questions right away. All right, I see a couple other people typing on Slack, so let me wait a minute and make sure that no one has any lingering questions before I call it quits. Sorry, guys, sit tight. We have someone typing. Oh, Monica asked a really great question. I'm really glad you asked this. So Monica said, because we learned that everything is an object, can we create properties and methods for those objects? And the answer is yes. So if we just have this array, of course, we have some built-in methods like pop, which gives us the last item on the array. So if we have pop, we get the last item on the array and it pops off, but we can also customize the array. So, so pop exists on something called the array prototype, and we will learn a lot more about prototypes tomorrow. So kind of suspend any questions you have about what the prototype is exactly. So I could do array.prototype, and this array object is kind of a global object that gives us access to what is this array costume, what does it contain? And then we could do something like get second. And then we could do return this. I believe you would do, haven't done this in a minute, but I think we could just do this dot one. Let me see if this works. Bear with me. And then let's try array.getSecond. Cool. So another little preview into why this becomes important, but this might be the actual details of what's going on here might not make sense, and we will cover that tomorrow. But the essence to take away here is that if we want to customize these array properties, if we want to add properties or methods onto the array, we are allowed to do that. So to get really anything on an object, we have to build it ourselves. But if we want to customize the methods that exist on these pre-existing types of objects like arrays, we are welcome to do that. So get second is not a method that is built into JavaScript. I just custom built that right here, and it gives us the second item in our array. So even if I change what's in here and add 1.5, now get second will give us this second item in here. So that's a little cool thing that we can do, that this idea that everything's secretly an object means that we can in fact add our own methods and properties on here. Okay, we have someone else typing. Let's sit tight for a minute. Is .prototype required to declare methods? I believe it is. Let me try to, well, let me show you something. So if I did array.getSecond, I'm experimenting a little bit. So I'm kind of answering this question for myself as well as you guys. So let's try this. Okay, cool. So now I have actually stuck this method on the array, on this specific array. So if instead I do array2, and now I'm going to try array.2. So what I've done in this example is I've put this method on one specific array. So this specific array has a getSecond method, but no other arrays do. But instead, if I use the prototype, like I did initially, I have put this on every single array. So now any new array that I create will have this. So generally, this is how we do it, because when well, I guess it might depend on use case. So if you want to create a new method that every single array can use, you would put it on the prototype. If you want to create a new method that only one specific array can use, you would put it on the array directly. So Mike asked if using .prototype makes it a global method. Yeah, so it's global in the sense that it applies to every single array. And we will talk a lot more about the prototype tomorrow. So we'll talk a little bit more about why it's really useful to stick things on the prototype. Okay, so Kristen wants to know, if you list every item on the array, does it list your new method with the values? So let's go ahead and take a look at that. That's another, you guys are asking great questions today, by the way. So this is a lot of fun. I'm glad we have a lot of time for questions. So I'm going to bring up that, 1 second. So let's go ahead and move this getSecond onto the first array itself. Array.getSecond. So now if I go ahead and log the array, yep, so something kind of confusing has happened over here. So getSecond actually appears on the array. So in that case, maybe this is not the best technique. This actually is a good example of why we would probably want to just put things on the prototype. Because now let's do a for loop on this array and see what happens. I bet that getSecond will appear. So if I do for, actually, let me just try array.3. Or sorry, array.4. So it's not in the 4th index. So if we do array.length, we see that it's only counting these 4 items. So if we loop through this thing, we're only going to get these 4 items. We wouldn't see this method. But instead, if we did a for in loop, an array, we now see that getSecond appears. So this is another reason why you wouldn't want to use a for in loop on an array, is that if you have a built-in method, it's going to pop up. And you really wouldn't think of this method as being something that's inside of the array. So, so hopefully that answers your question, Kristen, that if you add a method directly onto a specific array instead of on the prototype, you can find it hiding in there using things like the for in loop, but it's not indexed on here. You wouldn't be able to look it up using one of the indices. And if you did a for loop, you wouldn't be able to see that method. All right, anyone else? Okay, I think we are going to call it a night then. Well, thank you so much for sticking with this tonight. I know that we had some mind-boggling things happen with this everything's an object reveal, and I'm actually feeling really good about your guys' comprehension of this, because you are asking really deep, detailed, interesting questions that let me know that you're starting to think about this in the right way. So I think that's really cool, especially because I know a lot of you guys had never even seen this stuff just last week. So that's great. All right, well, that is it for tonight. I'm excited for tomorrow because we actually touched on kind of the beginnings of everything we're going to see tomorrow with some of these questions. So I hope you guys are excited to dive a little bit more into the prototype and customizing methods. And we're even going to look into how to build something called a class, which is essentially custom building our own type in JavaScript. So that will be tomorrow night. Good luck with the homework, and definitely reach out in Slack if you get stuck. Okay, I will see you guys tomorrow. Have a great night.